I am Dr. Abrar Ahmad, Associate Professor, Head Department of Mathematics, JN College Dhurwa, Ranchi University, Ranchi. Today I am going to present a lecture for the semester 3 and the paper C6, that is solution of system of linear equations via matrix method and consistency and inconsistency of the matrix. Now, it has been already shown that any system of simultaneous linear equation can be expressed in the form of the matrix Ax equal to B, where A is the matrix of the coefficients, X is the column matrix of unknown variables, and B is the column matrix of known elements which are independent of variables. Now the matrix of Ax equal to B, by multiplying A inverse, we get A inverse Ax equal to A inverse B, that is X equal to A inverse B. That is a method of finding the solution of simultaneously linear equation. Now there are some rules that the determinant of A is not equal to 0, then system is said to be consistent and has a unique solutions. There is another rule: if determinant of A equal to 0, the system of equation has either no solutions or infinite number of solutions. Number 3, if adjoint of A multiplied a matrix B is not equal to 0, the system has no solution and is therefore inconsistent. And another one, if adjoint of A into a matrix B equal to 0, the system is consistent and it has many solutions. In this case, the equations are dependent equations. Now we give an example. Solve the equation by matrix method. We take equations x minus 2y plus 3z equal to 5, number 1, then 4x plus 3y plus 4z equal to 7, and x plus y minus z equal to minus 4. Here we take the matrix A equal to the coefficient of x, y, z in the first row, that is 1 minus 2 3, in the second row 4 3 4, and in the third row 1 1 minus 1, that is matrix A, and x is the column matrix x, y, z, and B is the node numbers, that is in column matrix 5 7 minus 4. Now we take the determinants of A, that is 1 minus 2 3 in the first row, in the second row 4 3 4, and 1 1 minus 1 in the third row, that is 1, and deleting the first row and first column value of the determinant, we know the method, 1 into then minus 3 minus 4 plus 2 into in bracket minus 4 plus 3 in bracket 4 minus 3. After calculating we get minus 20, that is different from 0. Therefore, if the determinant of A different from 0, that is A is non-singular. The next step consists in finding out the inverse of A. Inversion of A, that is, now consider the matrix B1 whose elements are the cofactors of the corresponding elements of determinant of A. That is, the cofactor of 1 is minus 7, cofactor of minus 2 is 8, cofactor of 3 is 1, cofactor of 4 is 1, cofactor of 3 is minus 4, cofactor of 4 is minus 3, cofactor of 1 is minus 17, cofactor of 1 is 8, and cofactor of minus 1 is 11. So we put in the corresponding elements of the cofactors, that is B1 equal to, in the first row minus 7 8 1, in the second row 1 minus 4 minus 3, and in the third row minus 17 8 11. We take the transpose of B1, that is the adjoint of A. So we can, in the first row we have minus 7 1 minus 17, in the second row 8 minus 4 8, and the third row 1 minus 3 11, that is adjoint of A. And the formula of A inverse is nothing but equal to the 1 by determinant of A into adjoint of A, that is 1 by minus 20, and then in the matrix form, in the first row 7 1 minus 7 7 1 minus 17. In the second row 8 4 minus 8. In the third row 1 minus 3 11. That is 7 by 20, and in the first row minus 1 by 20, 17 by 20, and the second row minus 2 by 5, in 1 by 5 and minus 2 by 5. In the third row minus 1 by 20, 3 by 20, minus 11 by 20. That is now x equal to A inverse B. X we can write in the matrix form in the column matrix x y z. Then 7 by 20 minus 1 by 20, 17 by 20 in the first row. In the second row minus 2 by 5, 1 by 5, minus 2 by 5, and in the third row minus 1 by 20, 3 by 20, minus 11 by 20, and the multiplied by the column matrix 5 7 minus 4. So x y z is nothing but the 7 by 4 minus 7 by 20 minus 17 by 5 in the first row. In the second row minus 2 plus 7 by 5 plus 8 by 5, and in the third row minus 1 by 4 plus 21 by 20 plus 11 by 5. That is minus in the first row minus 2 1, in the column matrix in the first column minus 2 1 3. So x equal to minus 2, y equal to 1, and z equal to 3. This is the solution. X equal to minus 2, y equal to 1, z equal to 3. Now test for consistency and solve the equation. Another example, very important, how to find the consistency and inconsistency. Take an example, 5x plus 3y plus 7z equal to 4, 3x plus 26y plus 2z equal to 9, and 7x plus 2y plus 10z equal to 5. The given system can be written in the matrix form Ax equal to B, that is in the first row 5 3 7, 3 26 to second row, and third row 7 to 10, and in the column matrix x y z, and that is equal to in the column matrix 4 9 5. Now take the determinant of A, 5 3 7, 3 26 2, and 7 2 10 in the third row. That is 5 in bracket 26 minus 4, then minus 3 in bracket 30 minus 14 plus 7 in bracket 6 minus 26 into 7. After calculating, that is 1280 minus 48 minus 1232, that is equal to 0. Therefore, A is singular and hence A inverse does not exist. Hence, the given system has no solutions and infinite solutions according as adjoint of A into B not equal to 0 or adjoint of A into B equal to 0 respectively. We now find adjoint of A. Consider a matrix B1 whose elements are the cofactor of the corresponding elements of determinant of A. That is B1 equal to 26 minus 4 in the first row, then minus 30 minus 14 in bracket, and 6 minus in bracket 7 into 26. Second row minus 13 in bracket 14, 50 minus 49, and then minus in bracket 10 minus 21, 6 minus in bracket 26 into 7, minus 10 minus 21 in bracket, and 26 into 5 in bracket minus 9. And after solving this, we get in the first row 256 minus 16 minus 176 minus 16 111 minus 176 11 121. Adjoint of A is nothing the B1 transport, that is in the first row 256 minus 16 minus 176 minus 16 111 minus 176 11 121. Now adjoint of A into B, that is in the first row 256 minus 16 minus 176, second row minus 16 111, and third row minus 176 11 121, and that multiplied by column matrix 4 9 5. That is, this is equal to 124 in the first row, 1024 minus 144 minus 830, in the second row minus 64 plus 9 plus 55 minus 705 plus 9 plus 605, in the column matrix 0 0 0 equal to 0. Hence the system is consistent, it has infinite solutions. Assume just j equal to k. The first two equation reduces to 5x plus 3y equal to 4 minus 7k, and 3x plus 26y equal to 9 minus 2k, which can be written in the form of the matrix as 5 3 in the first row, 3 26 in the second row, and the column matrix x y z, and then 4 minus 7k, 9 minus 2k, or Cx equal to D, where C equal to 3 2, 3 26, and x equal to x, y, z, and d equal to 4 minus 7k and x minus 2k, where c equal to the determinant in the first row 5, 3, 326, that is equal to 121, which is different from 0. Now consider the matrix C1 whose elements as the cofactor of the corresponding elements of the determinant C. Now C1 is nothing but in the first row 26 minus 3, in the second row minus 3, 5, that is C1 dash is in the first row 26, take C1 dash meaning thereby the transpose of C1, that is the adjoint of C, in the first row 26 minus 3 and in the second row minus 3, 5. So C inverse is nothing but the determinant of 1 by C into adjoint of C, that is 121, and the matrix C1 dash, that is adjoint of A. So C1 C inverse x equal to C inverse D, that is 121, and the matrix in the first row 26 minus 3 and minus 3, 5, and then the matrix 4 minus 7k and 9 minus 2k. So 121, and in the first row 26 in bracket 4 minus 7k minus 3 in bracket 9 minus 2k, in the second row minus 3 in bracket 4 minus 7k plus 5 in bracket 9 minus 2k. After solving we get 100 by 21, and in the first row 1 minus 176k plus 77, in the second row 11k plus 33. So this is equal to x in column matrix xy. So x equal to 1 by 21 minus 176k plus 77, that is 1 by 11 in bracket minus 16k plus 7, and y equal to 1 by 11 in bracket k plus 3. Hence the solution is x equal to minus 16k plus 7 by 11 and y equal to k plus 3 by 11 and z equal to k. This is the solutions x, y, z, and I hope you understand the solution of system of linear equation and how to find the consistency of the equation and inconsistency of the equation. Once again, thank you very much.